Elon Musk's Starship isn't just a rocket. It's a towering juggernaut poised to rewrite the rules of space exploration. Right now, its current iteration, version 1, V1, stands as the largest launch system ever to pierce the sky, a 121-meter colossus that looms over the legendary Saturn V like a skyscraper over a bungalow. Powered by an array of Raptor engines, marvels of engineering with a thrust-to-weight ratio that leaves competitors in the dust. This two-stage beast is already a game-changer. But if you think that's the pinnacle, buckle up, because SpaceX is just getting started. The next-generation Starship V2 is slated to roar into orbit in 2025, capable of hauling 100 tons of cargo with upgrades that'll make your head spin. Then there's V3, a 150-meter Titan packing 10,000 tons of thrust, a rocket so absurdly capable it could assemble the International Space Station in 2 flights, not the 60 it took the Space Shuttle. And just when you thought it couldn't get crazier, whispers are swirling about a version 4, V4, an 18-meter-wide behemoth that quadruples the cargo capacity of its predecessors. This isn't science fiction, it's SpaceX's next move, and it might just blow your mind. Let's rewind for a second. SpaceX, the brainchild of Elon Musk, didn't just stumble into this. The company has spent 2 decades shaking up the aerospace world, turning the idea of reusable rockets from a pipe dream into a reality that's left NASA and old-school rocket makers scrambling to catch up. Their Falcon 9 proved rockets could land and fly again, slashing launch costs to a fraction of what they once were. But Starship, it's the crowning jewel of Musk's relentless push to make humanity a multiplanetary species. The current V1 is a marvel. 121 meters tall, with its super heavy booster. It's a stainless steel Titan that shrugs off the heat of re-entry like it's nothing. Those Raptor engines, 33 of them in the booster alone, crank out 230 tons of thrust each, giving V1 a lift-off power that dwarfs anything else humanity's ever built. It's not just big, it's smart, designed to be fully reusable, cutting the astronomical costs of spaceflight down to something suspiciously affordable. But Musk doesn't sit still. Starship V2 is already in the pipeline, and it's a leap forward that's got engineers drooling and skeptics raising eyebrows. Set to debut in 2025, V2 will hoist 100 tons to low Earth orbit, a payload capacity that starts to make space feel less like a frontier and more like a highway. The upgrades are where it gets juicy. Take the forward flap system. In V1, these aerodynamic control surfaces sat 180 degrees apart from the aft flaps, a design that looks slick on paper but turned into a headache during descent. As Starship plunges back through the atmosphere, those forward flaps generated lift that yanked the nose upward, forcing the aft flaps to compensate like a seesaw in a storm. Worse, even when retracted, parts of the forward flaps, along with a static aero component, stuck out, adding drag where it wasn't wanted. Musk himself called it out on X. There's a slight error with forward flap design. Moving section is needed for control, but passive section is counterproductive as it pushes nose backwards. His fix: rotate the flaps to the leeward side, think the downwind part of the spacecraft, and shift them forward to tweak the moment arm, landing them maybe 120 degrees apart. In V2, that's exactly what SpaceX did. The forward flaps are now fully relocated to the leeward side, tucked behind the nose cone when retracted, slashing drag and stabilizing descent like a dream. It's not just a tweak, it's a rethink that makes V2 a smoother, more efficient beast. And that's just the start. The nose cone's been beefed up, the header tank reinforced, and SpaceX has tossed in wild new features. A PEZ dispenser for spitting out satellites mid-flight and specialized gear for catching the rocket with a launch tower on landing. This isn't just about getting to space. It's about doing it repeatedly, cheaply, and reliably. V2's upgrades scream durability. A rocket built to shrug off the wear and tear of back-to-back missions with minimal pit stops. But if V2 is a leap, V3 is a quantum jump. Picture this: 150 meters tall, the tallest rocket ever conceived, dwarfing even the Saturn V's 110 meters. With an array of Raptor engines pumping out a combined 10,000 tons of thrust at sea level, V3 isn't just powerful, it's a force of nature. Its payload capacity is projected to hit 200 tons to orbit, double that of V2. To put that in perspective, the International Space Station weighs 420 tons and took 60 space shuttle flights to assemble over a decade. V3 could do it in two flights. That's the kind of efficiency that turns space from an elite playground into a bustling frontier. And here's the kicker. SpaceX aims to launch V3 for $2 to $3 million a pop. Compare that to Falcon 1's $10 million per launch back in 2008, and you see why jaws drop. Full reusability, paired with a design that cuts refurbishment time to the bone, makes V3 not just a rocket, but a revolution. Now let's talk about the rumor that's setting the internet ablaze. Starship V4, an 18-meter-wide monster that makes everything before it look like a toy. The current Starship is 9 meters across, already wider than Saturn V's 10-meter first stage, or the Soviet N-1's 17-meter base. Double that to 18 meters and you're not just scaling up, you're rewriting the playbook. Here's the math. For a rocket of the same height, doubling the diameter quadruples the volume. That means V4 could carry 4 times the cargo or passengers of V3. Think 800 tons to orbit or hundreds of people in one go. Imagine launching an entire space station, fully assembled, in a single mission, or ferrying a small army of colonists to Mars. This isn't incremental, it's exponential. Powering that beast is where it gets hairy. The Super Heavy booster for V1 and V2 uses 33 Raptor Fit-2 engines, each at 230 tons of thrust, for a total of about 7,590 tons at liftoff. V3 bumps that to match its 10,000-ton goal. But V4? To lift an 18-meter-wide rocket, you're looking at a payload and structural weight that could demand 30,000 tons of thrust or more. With Raptor 3 engines already climbing to 280 tons each, and Musk hinting at 300 tons in the works, you'd need over 100 engines, maybe 130, crammed into that booster. Or, and this is where it gets nuts, SpaceX could unveil a whole new engine, something bigger, with a beefier turbine to cut down on the engine count and simplify maintenance. Either way, V4 would be a symphony of raw power, a rocket that doesn't just launch, it thunders. So why go this big? The answer is Musk's obsession. Mars. Colonizing the red planet isn't a weekend project. It means hauling thousands of tons of gear, habitats, food, equipment, you name it, and potentially thousands of people. Musk's 2016 interplanetary transport system pitched a 12-meter-wide Starship, needing 1,000 launches per Mars transfer window every 26 months, plus thousands of orbital tanker flights to refuel them. An 18-meter V4 could slash that to 250 Mars-bound ships, cutting tanker missions from 3,750 to under 1,000. It might even ditch orbital refueling depots entirely, streamlining the whole insane operation. Lunar missions? V4 could drop an entire base in one shot, accelerating humanity's foothold on the moon. This isn't just about size, it's about making the impossible practical. But let's not kid ourselves. Building V4 is a Herculean task. An 18-meter rocket needs a new factory. Think bigger bays, thicker steel, massive tank farms. The current Boca Chica launch pad would choke under the heat and vibration of 130 Raptors firing at once. SpaceX would need a whole new setup, maybe water-cooled to survive the inferno. The Mechazilla tower that catches Starship today? It'd buckle under V4's mass. Landing legs might make a comeback. Transporting this thing is a nightmare. No road can handle it, so SpaceX might build and launch it on site. And the red tape? Years of environmental tests, shock waves, emissions, safety could stall it. Think Sea Dragon, a 1962 Navy concept, 23 meters wide, 150 meters tall, ocean-launched to dodge infrastructure woes. It promised 550 tons to orbit but died when Apollo faded and Vietnam ate the budget. V4's echoes of that ambition show Musk's not afraid to dream bigger than history. So how powerful could V4 be? Picture a rocket that launches cities, not payloads, a machine that turns Mars from a dream into a destination. Its combo of size, thrust, and cost efficiency could flip space exploration on its head, making it as routine as air travel. Genius or madness? Musk's betting on the former, and SpaceX's track record says he might pull it off. Drop your take. Is this the future or a billionaire's fever dream?